All right, hello everyone. This is my next video in the series on Module 3A, which is going to be talking about ways to optimize memory. And in this particular video, we're going to talk about how best to schedule your study time, which, spoiler alert, the best way to schedule your study time is to use a distributed practice schedule, or a schedule that incorporates something called spacing. So in my last video, I talked about some of the common study habits that college freshmen typically engage in. So for example, a lot of them said that they like to reread their notes and textbook chapters and engage in kind of a passive restudying of information. A lot of them said they like to take practice tests, but only after studying and only those that were provided for them. And a lot of them said that they like to cram for exams, and they like to study in one place. And 80% of our sample said that this statement, which was true, which is if I learn in just the right way, learning will be easy, right? So my videos for this particular module are going to challenge the efficacy of a lot of these different study habits. So we've already talked about why rereading isn't as effective a strategy as testing yourself or engaging in what's called retrieval practice. And I've talked about not only how retrieval practice is helpful instead of studying something, or more helpful than studying something, but I've also talked about test potentiated learning, right? Or the notion that taking a practice test or engaging in retrieval practice even before you study something is going to be helpful because you're going to be able to get more out of that particular study session, right? But what we're going to focus on today are the next two bullet points, which is cramming for exams and also studying in one place. Okay, so let's go ahead and get started. Okay, so what does research in cognitive psychology suggest about how you should schedule your study time? Well, there's actually over 100 years worth of research on this particular question, and that centuries worth of research all supports one particular conclusion. Okay, so I'm basically going to show you a hypothetical experiment that is actually not a singular experiment, but many, many different experiments kind of combined, right? So again, in this particular hypothetical experiment, in one group of participants, we might give them a passage, maybe the same passage that Roediger and Karpicki used about the sun or sea otters, and have them read that passage for 5-minute intervals 3 times consecutively, right? So 15 minutes of studying a passage back to back. Okay, and in another group, we give them 5 minutes of studying, okay, and then we have an interval where they're not studying, or we space their study sessions out in time, right? So maybe we have them study a passage for 5 minutes and then do math problems for 5 minutes, and then study the passage again for 5 minutes, do math problems for 5 minutes, and then study the passage a final time. Okay, and then we're going to be looking at their performance 5 minutes after their last study session, as well as a week later, right? So what we see on this immediate test if we were to compare these two groups, is in the cramming group, which is in red, right? So the cramming group, or massing group, as it's sometimes called, where all of your study sessions are massed together in time, at least initially on that 5-minute test, your recall is going to be at about 80%, right? So you're going to be able to recall about 80% of those 30 idea units from that sea otter's passage, right? Whereas the people who had their study sessions spaced out in time are going to be at about 70, right? But if we now compare performance 1 week later, we again see the inverse, right? So people who engaged in a massing or cramming strategy in red are now only going to be able to recall about 50% of the passage, whereas those who engaged in a spacing strategy are going to be able to retain most of the information that they learned initially. And this is the pattern that seems to be confirmed by countless research studies, regardless of the type of information being learned, like I said, regardless of the demographics of your participants, whether they are college-age adults, older adults, children. This pattern does seem to hold, that if we're talking about long-term retention of information, it's going to be much, much better if you space your study sessions out in time or engage in distributed practice, as opposed to cramming or massing all of your study sessions together. Right. So again, take-home message, cramming is good if you take the test within a few hours and never need that information again, okay? Because you will forget that information very, very rapidly. Cramming is bad when you want to retain that knowledge over an extended period of time, right? So for a class with several cumulative midterms or a cumulative exam, okay, cramming would be a bad strategy. Cramming would also be a bad strategy for science majors, psychology majors, neuroscience majors, physics majors, chemistry majors, biology majors. Anyone who needs to retain concepts from an introductory class when taking more advanced classes, right? In order to understand what's happening in Gen Chem 2 or O Chem 1, right? You need to retain the information from Gen Chem 1. And similarly for physics or any other particular domain that you're talking about, right? Unless you are taking a class that has absolutely no relevance to you in your future coursework, then this distributed practice strategy is going to be essential so that you can retain that information. Okay, so the last thing I want to talk about in this video is why spacing is good if you want to remember information long term. So there's 3 particular theories that I'm going to talk about. Okay, the first theory has to do with attention, right? So one of the drawbacks of massing or cramming is the effect that it has on your ability to stay focused or pay attention, right? So massing or cramming gets really boring, right? So imagine that you're studying for a neuroscience exam and you've been looking at the same notes for 8 hours, right? Are you going to be able to sustain the same degree of focus that you had when you first cracked open your book or your notes or your laptop in hour 1 at hour 8, right? Probably not. You're going to be bored, you're going to be fatigued, okay? And that's going to decrease the amount of attention or focus that you devote to the information. And as we know from the modal model of memory, right, information or attention rather is going to be essential for you to encode information from your immediate consciousness or your short-term memory into long-term memory, right? So if you can't sustain that attention, then there's really no hope that it will be encoded and retained. Okay. The second theory has to do with retrieval practice, right? So in my last video, I was really emphasizing how retrieval practice is one of the most effective strategies that you can use if you want to remember information long term, right? Well, if you mass all of your study sessions together or cram them, right, that information is going to be very, very accessible, right, because you have just looked at it for an extended period of time, right? As we saw in the previous example, people that studied the passage for 20 minutes straight, right, they're able to retain about 80% of that passage, at least in the short term, right? So there's not going to be a lot of opportunities for you to actively retrieve anything from long-term memory, right? Because it's all still very accessible to you. It's in your immediate conscious or your short-term memory, so you don't have to try to get anything out of long-term memory. But if you were to, again, study for 1 hour for 8 days, right? So if you study for 1 hour on day 1 and come back to the same information on day 2, chances are there's going to be natural forgetting, right? There's going to be interference from all of the classes that you've had during the day and other information that you've read. Plus, just with the passage of time, your memory for that information is going to be, there's going to be some natural forgetting that happens, right? And so instead of the information still residing in your short-term memory or your immediate consciousness, right, you now have to actively engage in retrieval to get that information from long-term memory into your short-term memory. And that retrieval attempt is going to make it easier for you to retrieve that information from long-term memory in the future. Okay, my final theory that I'm going to talk about for why spacing is such an effective strategy for promoting long-term learning has to do with variability. So one of the most important properties of long-term memory is the importance of what are called retrieval routes. So I mentioned that long-term memory has a permanent duration and an unlimited capacity, right? And that means that once something resides in long-term memory, it's permanent, right? It's kind of stuck there forever. But there's a lot of flexibility in terms of whether or not you'll be able to access the information stored in long-term memory or not. And one of the deciding factors that determines whether you'll have a successful retrieval from long-term memory or not is the kinds of cues that you have, right? So is there something in your environment or even in your internal state that is going to help you prompt you, if you will, to retrieve that information, right? So when we talk about retrieval routes, we talk about a particular event or stimulus becoming associated with something in your long-term memory so that whenever you see it or think about it, that memory is going to come up for you. And one of the most effective sorts of cues in terms of prompting retrieval of information is going to be, like I said, things happening in your environment or your internal state, right? And why that's important is the fact that whenever we learn something, whenever something gets encoded into our long-term memory, it doesn't get encoded by itself, right? It doesn't get encoded in a vacuum. Instead, it becomes sort of automatically associated with everything happening around you. It becomes associated with the people that you're with, or various things happening in your environment. So are there any objects in the room? Is there a particular smell in the room? Are there any lighting cues in the particular area where you are? And also your internal state, whether you're happy or sad, or drunk or sober, all of those things, believe it or not, are things that become associated with whatever memories are being formed at that particular time, right? So let's imagine that you're engaging in this distributed practice or the spacing strategy. So on day one, so you have decided that you're going to study for 8 hours, but instead of cramming them all together, you're going to study for 1 hour for 8 days prior to your exam. So let's say on day one, you decide to study in your dorm room, right? And on that particular day, it's very rainy outside, and you're having kind of a down day. So you're feeling sort of sad, sort of blue, right? What that means is that any information that you're studying is going to become associated with those particular qualities in your memory, right? So you're going to form retrieval routes between your mood, between the lighting and the weather that's happening outside, and your particular location. But let's say on day two, it's sunny, it's really, really bright and warm outside. You found out that you got an A on another exam or a paper, so you're in a really good mood, and you decide to study in the library, which isn't a small space like your dorm room. Might have been a particularly small room, whereas the place that you select in the library is very large, and it has, recessed lighting and a totally different sort of ambiance to it, right? So what that means is that now you're associating that same information with a totally different set of cues. So now you're able to retrieve the information when you're happy, when you're sad, when it's raining, when it's sunny, etc. Right? So basically, by associating the information with all of these different environmental cues and all of these different internal states, you're building more retrieval routes with which you can access this information later on. Right? So why is spacing an effective strategy, or distributed practice an effective strategy? Because when you're engaging in cramming, you're unable to sustain your focus on that information as effectively for an extended period of time as you would for a shorter period of time. There's also natural forgetting that happens when your study sessions are spaced apart in time, and that natural forgetting means that because the information no longer resides in your short-term memory, you have to engage in retrieval practice in order to get that information out of your long-term memory. And lastly, distributed practice, provided that you are in changing circumstances, right, between study sessions, means that you are going to build several different retrieval routes, associating the information with your fluctuating environments and your fluctuating moods, and therefore giving you a wide body of cues that you can use to later access the information. Okay, all right, so this concludes my video on why spacing is an effective strategy to promote long-term learning of information, and I will see you in my next video.